Yeah, hi guys. Yeah, welcome back once again to the object-oriented programming. Right, we are in session 5, as I told you before. So right now our topic is like Java collection framework, right? So the important question that we have to answer right now is what consists of Java collection framework. So Java collection framework consists of so many frameworks, that means so many interfaces, because okay, if you go and check it out, the interface collection with a generic type E, okay, consists of the interface that is a list. Okay, so it's like consists of a subclass that is a list, right? So with this, so the idea is there is also this collection implements also the interface that is a iterable interface. Okay, so we can also see that there is a map interface, like with the class, right? Hash map and the tree map, right? So most used classes, so you can, the most used classes, collection classes are array list and linked list, which implements the interface list. And the most used map collection classes are hash map and tree map, which implements interface map. We will discuss like all these two concepts later on in detail, right? And also we can use like other classes like hash set and tree set, which also implements the tree like interface set. But overall the mostly used interfaces and corresponding classes are these two interfaces, like list interface and the map interface, and the corresponding classes are the array list, linked list, and the hash map and the tree map. So as you can see here, as the collection interface implements the iterable interface, right? So why do we implement the iterable? Is for the simple point of within a simple point of view, we use this iterable implements is like we help us in it helps us in iteration, right? So what is this iterable interface? Okay, this interface is mostly used to iterate the container of elements. The container of elements is the collection elements, okay, a collection container. So it just helps us to iterate, okay. And then similarly, this interface consists of a single method, that is the iterator method, okay. The return type is a iterator, okay. And similarly it just returns the iterator on the elements. So what is the use of iterator interface? The use can be like you can have multiple uses, but the most important use is this provides a advanced mechanism, like to loop through all the elements of a collection bucket. What kind of advanced mechanism does it have? Is like it like auto increment on the elements occurs, okay, whereas you can keep the track of the last visited elements, so everything occurs here. So what is the iterator class then? This class allows the iteration on the elements of a collection. It consists of two main methods, okay. So we have a hasNext method and now we have a next method. So the idea is like hasNext method returns a boolean type. So what does it do is it just checks, okay, if there is a next element to iterate or not, okay. So if it returns true, that means it has the next element, whereas if the next method returns the next element, the iterated next element, and this advances by just one position, okay. So just one by one. So we can see a particular example here. Like, what is the example? You can see there is a user object, okay, with the assigned like parameters are passed through the user elements, the new user the object, okay, and for you can iterate in such form, like for, okay, the iterator, you create a iterator object from the collection iterator. This iterator returns iterating element, okay, object, and it checks for if it has a next iterating element or not. So if it has a next iterating element, then we go through the for loop. Then we can say that we can assign a new user to a next user. Yeah, the next user is a new next object that is assigned here. Okay, so this next object iterated, and then we just print out the next object element in a string format. So either you can use this or not. Okay, you can just directly also print out the particular object, right? So going through all this thing, now in the next question we can see that what says that what does collection interface contains. Okay, collection interface, it consists of a group of elements which consist of the reference to the object. Okay, so overall it's a bucket. Okay, it's a collection bucket in which you have a collection of the objects, and it's not only object, it's a reference to the objects. Okay, and all this reference to the object may be ordered or disordered, duplicated or not duplicated. So these collection elements are either ordered or disordered, duplicated or not duplicated. So some of the most used method in the collection interfaces are, you can see here, like the size, in size, boolean contents, right, and boolean add methods. So what is this size method? It's like it gives the size of the collection, whereas the contents method, it checks out if the collection contains following object elements, right? And about the boolean add method, we can add a new collection elements here, and like a simple example is given here below is like, okay, you can see that a collection of element of product, of object element product, and you create a collection element, it's like a products. Okay, and then you create a new array list of collection, then the products, okay, collection is added in the products. Okay, then we check out if the collection variable product contains the particular object. Okay, then we can just print out the product size of the collection. Okay, so what is the list interface then? Okay, so list interface is something that is like an interface which already extends a collection interface and can contain duplicate elements. So the idea is like, it's something that extends. If you can check out here, like, the list, it implements the collection element, collection interface, and this collection interface implements the iterable interface. Okay, and so it goes on. It goes in a tree, hierarchical tree, right? In the interface hierarchy. So yeah, going through all the collection interface. Yeah, so the next important point about the list interface is the order of insertion is preserved. Okay, the insertion order is preserved. This means like, okay, the first order. Okay, and whenever you insert, okay, the first insertion, and whenever you insert the second insertion, the insertion order is very preserved here. So whenever you add, the first elements is added, and then the second elements is added, whichever object element is added, okay, is just its the order is preserved. Okay. Okay, so why, and this advanced feature of preserving the order is very important when you want to access the particular element of the particular position, right? So it consists of of two most used classes, that is array list and the linked list. Okay, and this interface consists of the two most. So what's the difference between array list implementation and the linked list implementation? So in the array list, we use the method like getAnd method, okay, and this getAnd method, the complexity of this getAnd method is a constant time, okay. So whereas we use the add method is also a constant time. The complexity for using the add method is also a constant. Whereas if you go and check out the linked list, to use the linked list, the getter method takes a linear time. So the difference between constant time and the linear time is like constant time is always a short time, like it's less time consuming, whereas a linear time is a time that can linearly increase, okay. So the idea is like the array lists are much better when you use getAnd method, okay, to get a specific object, whereas the linked lists are better when you are using the add method, okay, to add the elements to the collection. So the point to be noted is like queue and the set interface, okay, these are not discussed in the topic here, okay, and you guys can go and check out the Java documentation for more information. But okay, so another note also says that the important concept about like while we are using the iterating, okay, while iterator of like interface, then what we have to be careful is we should not modify the collection, modify like adding or deleting the items, okay, object items. So we have to, what we do usually is like we have to use the iterator method, okay, to do these activities. So what kind of iterator method we can use to perform such kind of activities are like iterator.add method, and whereas also the iterator.remove method, okay. So this can be just performed, right? So what is the map interface here? Yeah, okay, we can see the map interface is we associate the key to the value in the map object, key to the value object. Both the key and the values may be objects, okay, both the key and the value must be objects. The idea, and the key cannot be unique. That means you cannot repeat the key, okay. Only one key is associated with the value, with one value of, okay. A key is associated to only one value, okay. A key cannot associate with 2 or 3 values, okay. So like collision might occur in this case. So some of the most important used method in the map interfaces are the put method. So we add the mapping, okay, values and keys here, okay. We put the mapping keys and values here, so we just get the particular value of the object from the get method, okay. So also correspondingly we also can use the important methods are also like contains key method, like the key set method, okay, and values method, which just returns the collection of values of the map collection. Yeah, you can also check out the particular example here, okay. The example says that like we create a new client D, okay, tree map. We create a new tree map collection, and in this tree map collection consists of a key that is a string and object that is a value that is a client object, whereas the string is a code and that is initialized to ABC. Whenever the collection map, and we can use the put method to add to map the key that is a code ABC to a new object. Okay, that is a client object. Okay, new client object with the value code. Okay, code detail. So, and we can also check out if the particular key contains in the client. So if the particular key contains in this map client, then we can just throw out the exception. Okay, we throw out the exception in this and say that like the code exists in this client. Two most used method in the map are like hash map, okay, where no order of key elements are transferred according to the keys. Get or put takes constant times. If there is no collision, then get and put method, like we have discussed here before, like get and put method, they just take a constant time. It's very fast. Okay, and this two most used class in the map, like hash map, is the important property of the hash map is there is no ordering. Okay, it can be arranged in any form. Okay, we can access this element, the values, in any order. Okay, in a random order. Okay, there is no ordering. Whereas while accessing the tree map, the key are arranged they are naturally arranged in some kind of ordering, some kind of ascending order. Okay, so the values that we retrieve are like in ascending order. Okay, now the question is about like how objects are sorted. Like, what is the basic principle of sorting? The basic principle of sorting is that to sort we have to compare between two objects, right? So comparing between two objects are there. So for this case we use and similarly for sorting in the objects in Java we use a comparable interface. What is a comparable? In comparable interface we use some kind of method to compare two objects, and you can see here that comparable interface just consists of only one method, that is compare to, and which takes a parameter object. Okay, now this compare to method can be overridden by any other class that implements this comparable interface. And the example is given here about how do you override a compare to method is like I have create a new train object. Okay, then I have tried to check out the difference of the year of this particular train object and also the of this particular year object of this of whichever class this object is, whichever class implements this compared to method interface, and that interface is has this method. Okay, and this method is overridden by this by a class. Okay, and this class is and the object of this class is used by the keyword this. Okay, the reference this is for whoever implements this method. Okay, and the difference is returned here. Okay, the return, like the integer value, the difference of the integer value is returned here. And whereas, okay, you can also see I just check out for the month, and I also check out for the days. Okay, and then I see. Okay, now this interface has just one method, right? as I told you before. And like what it does is just similarly it just the object one calls this method and just compare itself with this another object. And we have to be more careful because the integer value, the method returns a integer value. So if a return value is less than 0, then this particular object precedes the second object that it is comparing with. Okay, and if the return value is equal to 0, then this particular object that is comparing has the same order as object 2. That means the objects are same. And whereas if the integer value that is returned is greater than 0, then this means this object that is comparing follows the object 2, okay, that it is comparing itself to. Okay, now for the idea, okay, we have some key points, some key idea, key concepts here. And the concept is like string objects are lexicographically ordered. That means it is ordered like as if in dictionary, okay, in an alphabetical way, whereas numbers and subclasses are ordered numerically. So that means from 1 to like 100 or something, like it starts from 1 to 3, like in such a order. Now lastly the concept about some costume costume comparison of the objects is like we have whenever we use the sort, some kind of static methods which are already present in the collection class can also be used. Okay, so this is like a costume comparison of objects. Like previously this was a general implementation of general implementation of how to sort and sorting is done by using the comparable interface. But also there are some kind of static methods which are already present in the collection class and which can be used to sort, okay, to perform a particular action, that is sort. And this works by using two methods, and first one is a sort, okay, and the parameter it takes is a list, okay. Whereas also there is a second method in which we also use the comparator object. Now in this example I will show you how this is done, just some idea, the concept about how to use this. And we create a list of balls, a new linked list, okay. Then we add some items to the new linked list, like with the attribute like the color and the ID, and the color are red, orange, blue is added, whereas the code 123 something 4231 3210 are added. So whenever you want to sort this collection items, okay, list of collection, then you just use this method, that is collection.sort method, okay. The collection class calls this particular method, okay. And whereas also the collection, whenever you want to sort just by the ID, then you can use this sort method providing the list of balls, and the new comparator object is also passed here, so that we can sort on the basis of the ID. So this was all about using, okay, this was all about the interface, and okay, this was about the Java collection framework and how to use it. So see you in the session 6, okay.